This is brought to you by the Praetorian on both YouTube and Facebook. The Hebrew or Jewish calendar, Halua Ha'ivri, is a lunisolar calendar used today predominantly for Jewish religious observances. It determines the dates for Jewish holidays and the appropriate it is used for religious purposes, provides a time frame for agriculture, and is an official calendar for civil purposes, although the latter usage has been steadily declining in favor of the Gregorian calendar. The present Hebrew calendar is the product of evolution, including a Babylonian influence. Until the Tannaitic period, approximately 10 to 220 CE, the calendar employed a new crescent moon, with an additional month normally added every 2 or 3 years to correct for the difference between 12 lunar months and the solar year. The year in which it was added was based on observation of natural agriculture with the modern creation era Anno Mundi. The Hebrew lunar year is about 11 days shorter than the solar year, and uses the 19-year Metonic cycle to bring it into line with the solar year, with the addition of an intercalary month every 2 or 3 years, for a total of 7 times per 19 years. Even with this intercalation, the average Hebrew calendar year is longer by about 6 minutes and 40 seconds than the current mean tropical year, so that every 217 years the Hebrew calendar will fall a day behind the current mean tropical year, and about every 238 years it will fall a day behind the mean Gregorian calendar year. The era used since the Middle Ages is the Anno Mundi epoch, Latin for in the year of the world, Hebrew, from the creation of the world. As with Anno Domini, AD or AD, the words or abbreviation for Anno Mundi, AM or AM, for the era should properly precede the date rather than follow it. AM 5780 began at sunset on September 29, 2019, and will end at sunset on September 18, 2020. Components: day and hours. The Jewish day is of no fixed length. Based on the classic rabbinic interpretation of Genesis 1:5, there was evening, and there was morning, one day. A day in the rabbinic Hebrew calendar runs from sunset, the start of the evening, to the next sunset. The same definition appears in the Bible in Leviticus 23:32, where the holiday of Yom Kippur is defined as lasting from evening to evening. Halakhically, a day ends and a new one starts when 3 stars are visible in the sky. The time between true sunset and the time when the 3 stars are visible, known as Kseit HaKochavim, is known as Bi'in Hashmashat, and there are differences of opinion as to which day it falls into for some uses. This may be relevant, for example, in determining the date of birth of a child born during that gap. There is no clock in the Jewish scheme, so that the local civil clock is used. Though the civil clock, including the one in use in Israel, incorporates local adoptions of various conventions such as time zones, standard times, and daylight saving, these have no place in the Jewish scheme. The civil clock is used only as a reference point, in expressions such as, Shabbat starts at. The steady progression of sunset around the world and seasonal changes results in gradual civil time changes from one day to the next based on observable astronomical phenomena. The sunset and not on man-made laws and conventions. In Judaism, an hour is defined as 1/12 of the time from sunrise to sunset, so an hour can be less than 60 minutes in winter, and more than 60 minutes in summer. This proportional hour is known as a sha'ah zemanet, lit. A time-related hour. A Jewish hour is divided into 1080 halakim, singular, hilek, or parts. A part is 3/1/3 seconds, or 1/18th minute. The ultimate ancestor of the hilek was a small Babylonian period called a barleycorn, itself equal to 1/72nd of a Babylonian time degree, 1 degree of celestial rotation. These measures are not generally used for everyday purposes. Instead of the International Date Line Convention, there are varying opinions as to where the day changes. One opinion uses the anti-meridian of Jerusalem, located at 144 degrees 47 minutes west, passing through eastern Alaska. Other opinions exist as well. The weekdays start with Sunday, day 1, or Yom Rishon, and proceed to Saturday, day 7, Shabbat. Since some calculations use division, a remainder of 0 signifies Saturday. While calculations of days, months and years are based on fixed hours equal to 1/24th of a day, the beginning of each halakhic day is based on the local time of sunset. The end of the Shabbat and other Jewish holidays is based on nightfall, Seth HaKachavim, which occurs some amount of time, typically 42 to 72 minutes, after sunset. According to Maimonides, nightfall occurs when 3 medium-sized stars become visible after sunset. By the 17th century, this had become 3-second magnitude stars. The modern definition is when the center of the sun is 7 degrees below the geometric, airless, horizon, somewhat later than civil twilight at 6 degrees. The beginning of the daytime portion of each day is determined both by dawn and sunrise. Most halakhic times are based on some combination of these 4 times, and vary from day to day throughout the year, and also vary significantly depending on location. The daytime hours are often divided into sha'ah zemaniyah, or halakhic hours, by taking the time between sunrise and sunset, or between dawn and nightfall, and dividing it into 12 equal hours. The nighttime hours are similarly divided into 12 equal portions, albeit a different amount of time than the hours of the daytime. The earliest and latest times for Jewish services, the latest time to eat chametz on the day before Passover, and many other rules are based on sha'ah zemaniyah. For convenience, the modern day, using sha'ah zemaniyah is often discussed as if sunset were at 6 p.m., sunrise at 6 a.m., and each hour was equal to a fixed hour. For example, halakhic noon may be after 1 p.m. in some areas during daylight saving time. Within the Mishnah, however, the numbering of the hours starts with the first hour after the start of the day. Weeks. The Hebrew week, Shavua, is a cycle of 7 days, mirroring the 7-day period of the book of Genesis in which the world is created. Each day of the week runs from sunset to the following sunset, and is figured locally. The weekly cycle, which runs concurrently with but independently of the monthly and annual cycles. Names of weekdays. The names for the days of the week are simply the day number within the week, with Shabbat being the 7th day. In Hebrew, these names may be abbreviated using the numerical value of the Hebrew letters, for example, Day 1, or Yom Rishon. Yom Rishon, abbreviated, meaning first day corresponds to Sunday. Yom Sheni, abbreviation meaning second day corresponds to Monday. Yom Shlishi, abbreviation meaning third day corresponds to Tuesday. Yom Revi, abbreviation meaning fourth day corresponds to Wednesday. Yom Shemishi, abbreviation equals fifth day corresponds to Thursday. Yom Shirshur, abbreviation meaning sixth day corresponds to Friday. Yom Shabbat, abbreviation, or more usually, simply Shabbat, meaning rest day corresponds to Saturday. The names of the days of the week are modeled on the 7 days mentioned in the creation story, Genesis 1. For example, Genesis 1:8. And there was evening, and there was morning. A second day corresponds to Yom Sheni, meaning second day. However, for days 1, 6, and 7 the modern name differs slightly from the version in Genesis. The seventh day, Shabbat, as its Hebrew name indicates, is a day of rest in Judaism. In Talmudic Hebrew, the word Shabbat can also mean week. So that in ritual liturgy a phrase like Yom Revi'i Shabbat means the fourth day in the week. Days of the week of holidays. The period from 1 Adar, or Adar 2, in leap years, to 29 Marcheshvan contains all of the festivals specified in the Bible. Pesach, 15 Nisan, Shavuot, 6 Sivan, Rosh Hashanah, 1 Tishrei, Yom Kippur, 10 Tishrei, Sukkot, 15 Tishrei, and Shemini Atzeret, 22 Tishrei. This period is fixed, during which no adjustments are made. There are additional rules in the Hebrew calendar to prevent certain holidays from falling on certain days of the week. These rules are implemented by adding an extra day to Marcheshvan, making it 30 days long, or by removing 1 day from Kislev, making it 29 days long. Accordingly, a common Hebrew calendar year can have a length of 353, 354, or 355 days, while a leap Hebrew calendar year can have a length of 383, 384, or 385 days. Months. The Hebrew calendar is lunisolar, meaning that months are based on lunar months, but years are based on solar years. The calendar year features 12 lunar months of 29, or 30 days, with an intercalary lunar month added periodically to synchronize the 12 lunar cycles with. Although originally the new lunar crescent had to be observed and certified by witnesses, the moment of the true new moon is now approximated arithmetically as the molad, which is the mean new moon to a precision of 1 part. The mean period of the lunar month, precisely, the synodic month, is very close to 29.5 days. Accordingly, the basic Hebrew calendar year is one of 12 lunar months alternating between 29 and 30 days. In leap years, such as 5779, an additional month, Adar I, 30 days, is added after Shabbat, while the regular Adar is referred to as Adar 2. 2. Justification for leap months. The insertion of the leap month mentioned above is based on the requirement that Passover, the festival celebrating the Exodus from Egypt, which took place in the spring, always occurs in the Northern Hemisphere's spring season. Since the adoption of a fixed calendar, intercalations in the Hebrew calendar have been assigned to fixed points in a 19-year cycle. Before this, the intercalation was determined empirically. Maimonides, discussing the calendrical rules in his Mishnah Torah, 1178, notes, by how much does the solar year exceed the lunar year? By approximately 11 days. Therefore, whenever this excess accumulates to about 30 days, or a little more or less, 1 month is added and the particular year is made to consist of 13 months, and this is the so-called embolismic, interpolated year. For the year could not consist of 12 months plus so and so many days, since it is said, throughout the months of the year, number 28:14, which implies that we should count the year by months and not by days. The Bible does not directly mention the addition of embolismic, or intercalary months. However, without the insertion of embolismic months, Jewish festivals would gradually shift outside of the seasons required by the Torah. This has been ruled as implying a requirement for the insertion of embolismic months to reconcile the lunar cycles to the seasons, which are integral to solar yearly cycles. Characteristics of leap months. In a regular, Kesedron, year, Marcheshvan has 29 days and Kislev has 30 days. However, because of the Rosh Hashanah postponement rules, Kislev may lose a day to have 29 days, and the year is called a short, chaser, year, or Marcheshvan may acquire an additional day to have 30 days, and the year is called a full, malay, year. The calendar rules have been designed to ensure that Rosh Hashanah does not fall on a Sunday, Wednesday, or Friday. This is to ensure that Yom Kippur does not directly precede or follow Shabbat, which would create practical difficulties, and that Hosanna Rabbah is not on a Shabbat, in which case certain ceremonies would be lost for a year. The 12 lunar months of the Hebrew calendar are the normal months from the new moon to the new moon. The year normally contains 12 months, averaging 29.52 days each. The discrepancy, compared to the mean synodic month of 29.53 days, is due to Adar I in a leap year always having 30 days. This means that the calendar year normally contains 354 days, roughly 11 days shorter than the solar year. Traditionally, for the Babylonian and Hebrew lunisolar calendars, the years 3, 6, 8, 11, 14, 17, and 19 are the long, 13-month years of the Metonic cycle. This cycle forms the basis of the Christian ecclesiastical calendar and the Hebrew calendar and is used for the computation of the date of Easter each year. During leap years Adar I, or Adar Aleph, first Adar is added before the regular Adar. Adar I is considered to be the extra month and has 30 days. Adar II, or Adar Bet, second Adar is the real Adar and has the usual 29 days. For this reason, holidays such as Purim are observed in Adar II, not Adar I. Years. The Hebrew calendar year conventionally begins on Rosh Hashanah. However, other dates serve as the beginning of the year for different religious purposes. Three qualities distinguish one year from another, whether it is a leap year or a common year, on which of 4 permissible days of the week the year begins, and whether it is a deficient, regular, or complete year. Mathematically, there are 24, 2 times 4 times 3, possible combinations, but only 14 of them are valid. Each of these patterns is called a kaviyah, Hebrew for a setting, or an established thing, and is encoded as a series of 2 or 3 Hebrew letters. See 4 gates. In Hebrew, there are 2 common ways of writing the year number, with the thousands, called major era, and without the thousands, called minor era. Thus, the current year is written as 5780, using the major era, and 780, using the minor era. Anno Mundi. In 1178 CE, Maimonides wrote in the Mishneh Torah that he had chosen the epoch from which calculations of all dates should be as the 3rd day of Nisan in this present year, which is the year 4938 of the creation of the world, March 22nd, 1178. He included all the rules for the calculated calendar and their scriptural basis, including the modern epochal year in his work, and beginning formal usage of the Anno Mundi era. From the 11th century, Anno Mundi dating became dominant throughout most of the world's Jewish communities. Today, the rules detailed in Maimonides' calendrical code are those generally used by Jewish communities throughout the world. Since the codification by Maimonides in 1178, the Jewish calendar has used the Anno Mundi epoch, Latin for in the year of the world, abbreviated AM, or AM, Hebrew, sometimes referred to as the Hebrew era, to distinguish it from other systems based on some computation of creation, such as the Byzantine calendar. There is also reference in the Talmud to years since the creation, based on the calculation in the Seder Olam Rabbah of Rabbi Jose ben Halofta, in about 160 CE. By his calculation, based on the Masoretic text, Adam was created in 3760 BCE, later confirmed by the Muslim chronologist al-Biruni as 3,448 years before the Seleucid era. An example is c. 8th century Baraita of Samuel. According to rabbinic reckoning, the beginning of year 1 is not creation, but about 1 year before creation, with the new moon of its first month, Tishri, to be called Molad Tohu, the mean new moon of chaos or nothing. The Jewish calendar's epoch, the reference date, 1 Tishri AM1, is equivalent to Monday, October 7th, 3761 BC in the proleptic Julian calendar, the equivalent tabular date, same daylight period, and is about 1 year before the traditional Jewish date of creation on 25 Elul AM1, based upon the Seder Olam Rabbah. Thus, adding 3760 before Rosh Hashanah, or 3761 after to a Julian year number starting from 1 CE, will yield the Hebrew year. For earlier years there may be a discrepancy. The Seder Olam Rabbah also recognized the importance of the Jubilee and sabbatical cycles as a long-term calendrical system, and attempted at various places to fit the sabbatical and Jubilee years into its chronological scheme. Occasionally, Anno Mundi is styled as Anno Hebraico AH, though this is subject to confusion with notation for the Islamic Hijri year. New Year. The Jewish calendar has several distinct New Years, used for different purposes. The use of multiple starting dates for a year is comparable to different starting dates for civil calendar years, tax or fiscal years, academic years, and so on. The Mishnah, c. 200 CE, identifies for New Year dates. The first of Nisan is the New Year for kings and festivals. The first of Elul is the New Year for the cattle tithe. The first of Tishri is the New Year for years, of the years of release, and Jubilee years, for the planting and vegetables. And the first of Shabbat is the New Year for trees, so the school of Shammai, and the school of Hillel say, on the 15th thereof. Two of these dates are especially prominent. One Nisan is the ecclesiastical New Year, i.e. the date from which months and festivals are counted. Thus Passover, which begins on 15 Nisan, is described in the Torah as falling in the first month, while Rosh Hashanah, which begins on 1 Tishri, is described as falling in the 7th month. Since Passover is required to be celebrated in the spring, it should fall around, and normally just after, the vernal, spring, equinox. If the 12th full moon after the previous Passover is too early compared to the equinox, a 13th leap month is inserted near the end of the previous year, before the new year is set to begin. According to normative Judaism, the verses in Exodus 12:1, 2 require that the months be determined by a proper court, with the necessary authority to sanctify the months. Hence the court, not the astronomy, has the final decision. Nowadays, the day most commonly referred to as the New Year is 1 Tishri, Rosh Hashanah, lit. Head of the year, even though Tishri is the 7th month of the ecclesiastical year. 1 Tishri is the civil New Year, and the date on which the year number advances. Tishri marks the end of one agricultural year, and the beginning of another. And thus 1 Tishri is considered the new year for most agriculture-related commandments, including Shida, Yovel, Maser Rishon, Maser Sheni, and Maser Ani. For the dates of the Jewish New Year, see Jewish and Israeli holidays 2000 to 2050, or calculate using the section conversion between Jewish and civil calendars. Leap years. The Jewish calendar is based on the Metonic cycle of 19 years, of which 12 are common, non-leap years of 12 months, and 7 are leap years of 13 months. To determine whether a Jewish year is a leap year, one must find its position in the 19-year Metonic cycle. This position is calculated by dividing the Jewish year number by 19 and finding the remainder. Since there is no year 0, a remainder of 0 indicates that the year is year 19 of the cycle. For example, the Jewish year 5780 divided by 19 results in a remainder of 4, indicating that it is year 4 of the Metonic cycle. Years 3, 6, 8, 11, 14, 17, and 19 of the Metonic cycle are leap years. To assist in remembering this sequence, some people use the mnemonic Hebrew word Guchadzat, where the Hebrew letters Gimel Vav Het Aleph Dalet Zay and Tet are used as Hebrew numerals equivalent to 3, 6, 8, 1, 4, 7, 9. The Kaviyah records whether the year is a leap or common. For Pesh Yuda, meaning simple and indicating a common year, and indicating a leap year, Miyubrit. Another memory aid notes that intervals of the major scale follow the same pattern as do Jewish leap years, with 2 corresponding to year 19, or 0 a whole step in the scale corresponds to 2 common years between consecutive leap years, and a half step to 1 common year between 2 leap years. This connection with the major scale is more plain in the context of 19 equal temperament, counting the tonic as 0, 0. The notes of the major scale in 19 equal temperament are numbers 0, or 19, 3, 6, 8, 11, 14, 17, the same numbers as the leap years in the Hebrew calendar. A simple rule for determining whether a year is a leap year has been given above. However, there is another rule which not only tells whether the year is a leap, but also gives the fraction of a month by which the calendar is behind the seasons, useful for agricultural purposes. To determine whether year n of the calendar is a leap year, find the remainder on dividing 7 times n plus 1 by 19. If the remainder is 6 or less, it is a leap year. If it is 7 or more, it is not. For example, the remainder of dividing 7 times 5780 plus 1 by 19 is 10. So the year 5780 is not a leap year. The remainder of dividing 7 times 5781 plus 1 by 19 is 17. So the year 5781 is not a leap year. This works because as there are 7 leap years in 19 years, the difference between the solar and lunar years increases by 7/19 months per year. When the difference goes above 18/19 month, this signifies a leap year, and the difference is reduced by 1 month. Rosh Hashanah postponement rules. To calculate the day on which Rosh Hashanah of a given year will fall, it is necessary first to calculate the expected molad, moment of lunar conjunction or new moon, of Tishrei in that year, and then to apply a set of rules to determine whether the first day of the year must be postponed. The molad can be calculated by multiplying the number of months that will have elapsed since some preceding molad whose weekday is known by the mean length of a synodic lunar month, which is 29 days, 12 hours, and 793 parts. There are 1,080 parts in an hour, so that 1 part is equal to 313 seconds. The very first molad, the molad Toho, fell on Sunday evening at 11.1113 in the local time of Jerusalem, or 3761/10/6, proleptic Julian calendar, 20:50:23.1 UTC, or in Jewish terms day 2, 5 hours, and 204 parts. In calculating the number of months that will have passed since the known molad that one uses as the starting point, one must remember to include any leap months that fall within the elapsed interval, according to the cycle of leap years. A 19-year cycle of 235 synodic months has 991 weeks, 2 days, 16 hours, 595 parts. A common year of 12 synodic months has 50 weeks, 4 days, 8 hours, 876 parts, while a leap year of 13 synodic months has 54 weeks, 5 days, 21 hours, 589 parts. The 2 months whose numbers of days may be adjusted, Marcheshvan and Kislev, are the 8th and 9th months of the Hebrew year, whereas Tishrei is the 7th month in the traditional counting of the months, even though it is the first month of a new calendar year. Any adjustments needed to postpone Rosh Hashanah must be made to the adjustable months in the year that precedes the year of which the Rosh Hashanah will be the first day. Just 4 potential conditions are considered to determine whether the date of Rosh Hashanah must be postponed. These are called the Rosh Hashanah postponement rules, or diat. If the molad occurs at or later than noon, Rosh Hashanah is postponed a day. This is called diat molad zaken, literally, old birth, i.e., late new moon. If the molad occurs on a Sunday, Wednesday, or Friday, Rosh Hashanah is postponed a day. If the application of Daya Molad Zaken would place Rosh Hashanah on one of these days, then it must be postponed a second day. This is called Diat Lo Adu, an acronym that means not, weekday, 1, 4, or 6. The first of these rules, Diat Molad Zaken, is referred to in the Talmud. Nowadays, Molad Zaken is used as a device to prevent the molad from falling on the second day of the month. The second rule, Diat Lo Adu, is applied for religious reasons. Another 2 rules are applied much less frequently and serve to prevent impermissible year lengths. Their names are Hebrew acronyms that refer to the ways they are calculated. If the molad in a common year falls on a Tuesday, after 9 hours and 204 parts, Rosh Hashanah is postponed to Thursday. This is Diat Gatard, where the acronym stands for 3, Tuesday, 9, 204. If the molad following a leap year falls on a Monday, more than 15 hours and 589 parts after the Hebrew day began, for calculation purposes, this is taken to be 6 p.m. Sunday. Rosh Hashanah is postponed to Tuesday. This is DAPBTUT Kappa T, where the acronym stands for 2, Monday, 15, 589. At the innovation of the sages, the calendar was arranged to ensure that Yom Kippur would not fall on a Friday or Sunday, and Hoshana Rabbah would not fall on Shabbat. These rules have been instituted because Shabbat restrictions also apply to Yom Kippur, so that if Yom Kippur were to fall on Friday, it would not be possible to make necessary preparations for Shabbat, such as candle lighting. Similarly, if Yom Kippur fell on a Sunday, it would not be possible to make preparations for Yom Kippur because the preceding day is Shabbat. Additionally, the laws of Shabbat override those of Hoshana Rabbah, so that if Hoshana Rabbah were to fall on Shabbat, certain rituals that are a part of the Hoshana Rabbah service, such as carrying willows, which is a form of work, could not be performed. To prevent Yom Kippur, 10 Tishrei, from falling on a Friday or Sunday, Rosh Hashanah, 1 Tishrei, cannot fall on Wednesday or Friday. Likewise, to prevent Hoshana Rabbah, 21 Tishrei, from falling on a Saturday, Rosh Hashanah cannot fall on a Sunday. This leaves only 4 days on which Rosh Hashanah can fall: Monday, Tuesday, Thursday, and Saturday, by Hebrew letters. Thus the Kaviyah uses the letters, and representing 2, 3, 5, and 7, for Monday, Tuesday, Thursday, and Saturday, to denote the starting day of the year. Deficient, regular, and complete years. The postponement of the year is compensated for by adding a day to the second month, or removing one from third month. A Jewish common year can only have 353, 354, or 355 days. A leap year is always 30 days long, and so can have 383, 384, or 385 days. A Hasira year, Hebrew for deficient, or incomplete, is 353, or 383 days long. Both Cheshvan and Kislev have 29 days. The Hebrew letterhead is used in the Kaviyah. A Kasidra year, regular, or in order, is 354, or 384 days long. Cheshvan has 29 days, while Kislev has 30 days. The Hebrew letter Kaf is used in the Kaviyah. A Shlema year, complete or perfect, also abundant, is 355, or 385 days long. Both Cheshvan and Kislev have 30 days. The Hebrew letter Shin is used in the Kaviyah. Whether a year is deficient, regular, or complete is determined by the time between two adjacent Rosh Hashanah observances and the leap year. While the Kaviyah is sufficient to describe a year, a variant specifies the day of the week for the first day of Pesach, Passover, instead of the year length. A metonic cycle equates to 235 lunar months in each 19-year cycle. This gives an average of 6,939 days, 16 hours, and 595 parts for each cycle. But due to the Rosh Hashanah postponement rules, preceding section, a cycle of 19 Jewish years can be either 6939, 6940, 6941, or 6,942 days in duration. Since none of these values is evenly divisible by 7, the Jewish calendar is exactly only following 36,288 metonic cycles, or 689,472 Jewish years. There is a near repetition every 247 years, except for an excess of 50 minutes 16 to 3 seconds, 905 parts. For gates, the annual calendar of a numbered Hebrew year, displayed as 12 or 13 months partitioned into weeks, can be determined by consulting the table of 4 gates, whose inputs are the year's position in the 19-year cycle, and its molad tishrei. The resulting type, Kaviyah, of the desired year in the body of the table is a triple consisting of 2 numbers and a letter, written left to right in English. The left number of each triple is the day of the week of 1 Tishrei, Rosh Hashanah, 2357. The letter indicates whether that year is deficient, D, regular, R, or complete, C, the number of days in Cheshvan and Kislev, while the right number of each triple is the day of the week of 15 Nisan, the first day of Passover or Pesach, 1357, within the same Hebrew year, next Julian/Gregorian year. The Kaviyah in Hebrew letters are written right to left, so their days of the week are reversed, the right number for 1 Tishrei, and the left for 15 Nisan. The year within the 19-year cycle alone determines whether that year has one or two Adars. This table numbers the days of the week and hours for the limits of Molad Tishrei in the Hebrew manner for calendrical calculations. That is, both begin at 6 p.m. Thus 7D18H0P is noon Saturday. The years of a 19-year cycle are organized into 4 groups: common years after a leap year, but before a common year, 1, 4, 9, 12, 15, common years between 2 leap years, 7, 18, common years after a common year, but before a leap year, 2, 5, 10, 13, 16, and leap years, 3, 6, 8, 11, 14, 17, 19, all between common years. The oldest surviving table of 4 gates was written by Saadia Jain, 892 to 942. It is so named because it identifies the 4 allowable days of the week on which one Tishrei can occur. Comparing the days of the week of Molad Tishrei with those in the Kaviyah shows that during 39% of years one Tishrei is not postponed beyond the day of the week of its Molad Tishrei, 47% are postponed 1 day, and 14% are postponed 2 days. This table also identifies the 7 types of common years and 7 types of leap years. Most are represented in any 19-year cycle, except 1 or 2 may be in neighboring cycles. The most likely type of year is 5 or 7 in 18.1% of years, whereas the least likely is 5C1 in 3.3% of years. The day of the week of 15 Nisan is later than that of 1 Tishrei by 1, 2 or 3 days for common years and 3, 4 or 5 days for leap years is deficient, regular, or complete years, respectively. History. Basic chronology in the biblical period. From very early times, the Mesopotamian lunisolar calendar was in wide use by the countries of the Western Asia region. The structure, which was also used by the Israelites, was based on lunar months with the intercalation of an additional month to bring the cycle closer to the solar cycle, although there is no mention of this additional month anywhere in the Hebrew Bible. From several verses in Genesis, Gen 7:11, 8:3:4, 8:13, 14, it is implied that the months are 30 days long. There is also an indication that there were 12 months in the annual cycle. Month names. Biblical references to the pre-exilic calendar include 10 of the 12 months identified by number rather than by name. Before the Babylonian exile, the names of only 4 months are referred to in the Tanakh. Aviv, first month, literally spring, Exodus 12:2, 13:4, 23:15, 34:18, Deuteronomy 16:1. Ziv, second month, literally light 1 Kings 6:1, 6:37. Ethanim, seventh month, literally strong in the plural, perhaps referring to strong rains, 1 Kings 8:2, and Bull, 8th month, 1 Kings 6:38. All of these are believed to be Canaanite names. The last 3 of these names are only mentioned in connection with the building of the first temple. Håkon Ulfgard suggests that the use of what is rarely used Canaanite, or in the case of Ethanim perhaps Northwest Semitic, names indicates that the author is consciously utilizing an archaizing terminology, thus giving the impression of an ancient story. During the Babylonian captivity, the Jewish people adopted the Babylonian names for the months. The Babylonian calendar descended directly from the Sumerian calendar. These Babylonian month names, such as Nisan, Iyar, Tammuz, Ab, Elul, Tishri, and Adar, are shared with the modern Syrian calendar, currently used in the Arabic-speaking countries of the Fertile Crescent, and the modern Assyrian calendar, indicating a common origin. The origin is thought to be the Babylonian calendar. The modern Turkish calendar includes the names Sabat, February, Nisan, April, Tammuz, July, and Elul, September. The former name for October was Tesrin. Past methods of dividing years. According to some Christian and Karaite sources, the tradition in ancient Israel was that 1 Nisan would not start until the barley is ripe, being the test for the onset of spring. If the barley was not ripe, an intercalary month would be added before Nisan. In the 1st century, Josephus stated that while Moses, appointed Nisan as the first month for the festivals, the commencement of the year for everything relating to divine worship. But for selling and buying, and other ordinary affairs he preserved the ancient order, i.e. the year beginning with Tishri. Edwin Thiele has concluded that the ancient northern kingdom of Israel counted years using the ecclesiastical new year starting on 1 Aviv, Nisan, while the southern kingdom of Judah counted years using the civil new year starting on 1 Tishri. The practice of the kingdom of Israel was also that of Babylon, as well as other countries of the region. The practice of Judah is continued in modern Judaism. Past methods of numbering years. Before the adoption of the current Anno Mundi year numbering system, other systems were used. In early times, the years were counted from some significant historical events, such as the Exodus. During the period of the monarchy, it was the widespread practice in Western Asia to use era year numbers according to the accession year of the monarch of the country involved. This practice was followed by the United Kingdom of Israel, the Kingdom of Judah, the Kingdom of Israel, Persia, and others. Besides, the author of Kings coordinated dates in the two kingdoms by giving the accession year of a monarch in terms of the year of the monarch of the other kingdom, though some commentators note that these dates do not always synchronize. Other era dating systems have been used at other times. For example, Jewish communities in the Babylonian diaspora counted the years from the first deportation from Israel, that of Jehoiakim in 597 BCE. The era year was then called Year of the Captivity of Jehoiakim. During the Hellenistic Maccabean period, Seleucid era counting was used, at least in land of Israel, under Greek influence at the time. The books of the Maccabees used the Seleucid era dating exclusively. As did Josephus' writing in the Roman period. From the 1st to 10th centuries, the center of world Judaism was in the Middle East, primarily Iraq and Palestine, and Jews in these regions also used Seleucid era dating, which they called the era of contracts, or documents. The Talmud states, Rav Aha bar Jacob then put this question: how do we know that our era of documents is connected with the kingdom of Greece at all? Why not say that it is reckoned from the Exodus from Egypt, omitting the first 1,000 years and giving the years of the next 1,000? In that case, the document is postdated. Said Rav Naaman, in the diaspora, the Greek era alone is used. He, Rav Aha, thought that Rav Naaman wanted to dispose of him anyhow, but when he went and studied it thoroughly he found that it is indeed taught, in a Baraita, in the diaspora, the Greek era alone is used. The use of the era of documents, i.e., Seleucid era, continued until the 16th century in the East, and was employed even in the 19th century among the Jews of Yemen. Occasionally in Talmudic writings, reference was made to other starting points for eras, such as destruction era dating, being the number of years since the 70 CE destruction of the Second Temple. In the 8th and 9th centuries, as the center of Jewish life moved from Babylonia to Europe, counting using the Seleucid era became meaningless, and thus was replaced by the Anno Mundi system. There is an indication that Jews of the Rhineland in the early Middle Ages used the years after the destruction of the temple. Leap months. When the observational form of the calendar was in use, whether or not an embolismic month was announced after the last month Adar depended on Aviv, i.e., the ripeness of barley, fruits of trees, and the equinox. On two of these grounds it should be interpolated, but not on one of them alone. It may be noted that in the Bible the name of the first month, Aviv, literally means spring. Thus, if Adar was over and spring had not yet arrived, an additional month was observed, determining the new month in the Mishnaic period. The Tanakh contains several commandments related to the keeping of the calendar, and the lunar cycle, and records changes that have taken place to the Hebrew calendar. Numbers 10:10 stresses the importance in Israelite religious observance of the new month, Hebrew, Rosh Chodesh, beginning of the month. In your new moons, ye shall blow with the trumpets over your burnt offerings. Similarly in Numbers 28:11. The beginning of the month meant the appearance of a new moon. and in Exodus 12:2. This month is to you. According to the Mishnah and Tosefta, in the Maccabean, Herodian, and Mishnaic periods, new months were determined by the sighting of a new crescent, with 2 eyewitnesses required to testify to the Sanhedrin to having seen the new lunar crescent at sunset. The practice in the time of Gamaliel II, c. 100 CE, was for witnesses to select the appearance of the moon from a collection of drawings that depicted the crescent in a variety of orientations, only a few of which could be valid in any given month. These observations were compared against calculations. At first, the beginning of each Jewish month was signaled to the communities of Israel, and beyond by fires lit on mountaintops. But after the Samaritans began to light false fires, messengers were sent. The inability of the messengers to reach communities outside Israel before mid-month, High Holy Days, Sukkot, and Passover, led outlying communities to celebrate scriptural festivals for 2 days rather than 1, observing the second feast day of the Jewish diaspora, because of the uncertainty of whether the previous month ended after 29 or 30 days. It has been noted that the procedures described in the Mishnah and Tosefta are all plausible procedures for regulating an empirical lunar calendar. Fire signals, for example, or smoke signals, are known from the pre-exilic Lakish Ostraka. Furthermore, the Mishnah contains laws that reflect the uncertainties of an empirical calendar. Mishnah Sanhedrin, for example, holds that when one witness holds that an event took place on a certain day of the month, and another that the same event took place on the following day, their testimony can be held to agree, since the length of the preceding month was uncertain. Another Mishnah takes it for granted that it cannot be known in advance whether a year's lease is for 12 or 13 months. Hence it is a reasonable conclusion that the Mishnaic calendar was used in the Mishnaic period. The accuracy of the Mishnah's claim that the Mishnaic calendar was also used in the late Second Temple period is less certain. One scholar has noted that there are no laws from Second Temple period sources that indicate any doubts about the length of a month or a year. This led him to propose that the priests must have had some form of computed calendar or calendrical rules that allowed them to know in advance whether a month would have 30 or 29 days, and whether a year would have 12 or 13 months. The fixing of the calendar. Between 70 and 1178 CE, the observation-based calendar was gradually replaced by a mathematically calculated one. The Talmuds indicate at least the beginnings of a transition from a purely empirical to a computed calendar. Samuel of Nahardia, c.165-254, stated that he could determine the dates of the holidays by calculation, rather than observation. According to a statement attributed to Yos, late 3rd century, Purim could not fall on a Sabbath nor a Monday, lest Yom Kippur falls on a Friday or a Sunday. This indicates that, by the time of the redaction of the Jerusalem Talmud, c. 400 CE, there was a fixed number of days in all months from Adar to Elul, also implying that the extra month was already a second Adar added before the regular Adar. Elsewhere, Rabbi Simon is reported to have counseled those who make the computations not to set Rosh Hashanah or Hosanna Rabbah on Shabbat. This indicates that there was a group who made computations and controlled, to some extent, the day of the week on which Rosh Hashanah would fall. There is a tradition, first mentioned by Hai Jayan, died 1038 CE, that Hillel B'Adar Yehuda in the year 670 of the Seleucid era, i.e., 358 to 359 CE, was responsible for the new calculated calendar with a fixed intercalation cycle. Later writers, such as Nachmanides, explained Hai Jayan's words to mean that the entire computed calendar was due to Hillel B. Yehuda in response to the persecution of Jews. Maimonides, 12th century, stated that the Mishnaic calendar was used until the days of Abai and Rava c. 320 to 350 CE, and that the change came when the land of Israel was destroyed, and no permanent court was left. Taken together, these two traditions suggest that Hillel b. Yehuda, whom they identify with the mid-4th century Jewish patriarch Iolos, attested in a letter of Emperor Julian, and the Jewish patriarch Elul, mentioned by Epiphanius, instituted the computed Hebrew calendar because of persecution. H. Greeks linked the introduction of the computed calendar to a sharp repression following a failed Jewish insurrection that occurred during the rule of the Christian Emperor Constantius and Gallus. A later writer, S. Lieberman, argued instead that the introduction of the fixed calendar was due to measures taken by Christian Roman authorities to prevent the Jewish patriarch from sending calendrical messengers. Both the tradition that Hillel b. Yehuda instituted the complete computed calendar, and the theory that the computed calendar was introduced due to repression or persecution, have been questioned. Furthermore, two Jewish dates during post-Talmudic times, specifically in 506 and 776, are impossible under the rules of the modern calendar, indicating that its arithmetic rules were developed in Babylonia during the times of the Geonim, 7th to 8th centuries. The Babylonian rules required the delay of the first day of Tishrei, when the new moon occurred after noon. Except for the epic year number, the fixed reference point at the beginning of year 1, which at that time was 1 year later than the epoch of the modern calendar, the calendar rules reached their current form by the beginning of the 9th century, as described by the Persian Muslim astronomer Al-Khwarizmi in 823. Al-Khwarizmi's study of the Jewish calendar describes the 19-year intercalation cycle, the rules for determining on what day of the week the first day of the month Tishri shall fall, the interval between the Jewish era, creation of Adam, and the Seleucid era, and the rules for determining the mean longitude of the sun and the moon using the Jewish calendar. Not all the rules were in place by 835. In 921, Aaron ben Meir proposed changes to the calendar. Though the proposals were rejected, they indicate that all of the rules of the modern calendar, except for the epoch, were in place before that date. In 1000, the Muslim chronologist al-Biruni described all of the modern rules of the Hebrew calendar, except that he specified 3 different epochs used by various Jewish communities being 1, 2, or 3 years later than the modern epoch. Calendar observance in Auschwitz. While imprisoned in Auschwitz, Jews made every effort to observe Jewish tradition in the camps, despite the monumental dangers in doing so. The Hebrew calendar, which is a tradition with great importance to Jewish practice and rituals, was particularly dangerous since no tools of telling of time, such as watches and calendars, were permitted in the camps. The keeping of a Hebrew calendar was a rarity amongst prisoners, and there are only 2 known surviving calendars that were made in Auschwitz, both of which were made by women. Before this, the tradition of making a Hebrew calendar was greatly assumed to be the job of a man in Jewish society. Usage in contemporary Israel. Early Zionist pioneers were impressed by the fact that the calendar preserved by Jews over many centuries in far-flung diasporas, as a matter of religious ritual, was geared to the climate of their original country. The Jewish New Year marks the transition from the dry season to the rainy one, and major Jewish holidays such as Sukkot, Passover, and Shavuot correspond to major points of the country's agricultural year such as planting and harvest. Accordingly, in the early 20th century, the Hebrew calendar was reinterpreted as an agricultural rather than a religious calendar. After the creation of the State of Israel, the Hebrew calendar became one of the official calendars of Israel, along with the Gregorian calendar. Holidays and commemorations, not derived from previous Jewish traditions, were to be fixed according to the Hebrew calendar date. For example, the Israeli Independence Day falls on 5 Iyar, Jerusalem Reunification Day on 28 Iyar, Yom HaAliyah on 10 Nisan, and the Holocaust Commemoration Day on 27 Nisan. Nevertheless, since the 1950s, usage of the Hebrew calendar has steadily declined, in favor of the Gregorian calendar. At present, Israelis except for the religiously observant conduct their private and public life according to the Gregorian calendar, although the Hebrew calendar is still widely acknowledged, appearing in public venues such as banks, where it is legal for use on checks and other documents, though only rarely do people make use of this option, and on the mastheads of newspapers. The Jewish New Year, Rosh Hashanah, is a 2-day public holiday in Israel. However, since the 1980s, an increasing number of secular Israelis celebrate the Gregorian New Year, usually known as Sylvester Night, on the night between December 31st and January 1st. Prominent rabbis have on several occasions sharply denounced this practice, but with no noticeable effect on the secularist celebrants. Wall calendars commonly used in Israel are hybrids. Most are organized according to Gregorian rather than Jewish months, but begin in September, when the Jewish New Year usually falls, and provide the Jewish date in small characters. Other practices. Karaite calendar. Karaites use the lunar month and the solar year, but the Karaite calendar differs from the current rabbinic calendar in several ways. The Karaite calendar is identical to the rabbinic calendar used before the Sanhedrin changed the rabbinic calendar from the lunar, observation-based calendar to the current, mathematically based calendar used in rabbinic Judaism today. In the lunar Karaite calendar, the beginning of each month, the Rosh Chodesh, can be calculated, but is confirmed by the observation in Israel of the first sightings of the new moon. This may result in an occasional variation of a maximum of 1 day, depending on the inability to observe the new moon. The day is usually picked up in the next month. The addition of the leap month, Adar 2, is determined by observing in Israel the ripening of barley at a specific stage, defined by Karaite tradition, called Aviv, rather than using the calculated and fixed calendar of Rabbinic Judaism. Occasionally this results in Karaites being 1 month ahead of other Jews using the calculated Rabbinic calendar. The lost month would be picked up in the next cycle when Karaites would observe a leap month while other Jews would not. Furthermore, the seasonal drift of the rabbinic calendar is avoided, resulting in the years affected by the drift starting 1 month earlier in the Karaite calendar. Also, the 4 rules of postponement of the rabbinic calendar are not applied, since they are not mentioned in the Tanakh. This can affect the dates observed for all the Jewish holidays in a particular year by 1 or 2 days. In the Middle Ages, many Karaite Jews outside Israel followed the calculated rabbinic calendar, because it was not possible to retrieve accurate Aviv barley data from the land of Israel. However, since the establishment of the State of Israel, and especially since the Six-Day War, the Karaite Jews that have made Aliyah can now again use the observational calendar. Samaritan calendar. The Samaritan community's calendar also relies on lunar months and solar years. Calculation of the Samaritan calendar has historically been a secret reserved to the priestly family alone, and was based on observations of the new crescent moon. More recently, a 20th century Samaritan high priest transferred the calculation to a computer algorithm. The current high priest confirms the results twice a year, and then distributes calendars to the community. The epoch of the Samaritan calendar is the year of the entry of the children of Israel into the land of Israel with Joshua. The month of Passover is the first month in the Samaritan calendar, but the year number increments in the 6th month. Like in the rabbinic calendar, there are 7 leap years within each 19-year cycle. However, the rabbinic and Samaritan calendar cycles are not synchronized. So Samaritan festivals notionally the same as the rabbinic festivals of Torah origin are frequently 1 month off from the date, according to the rabbinic calendar. Additionally, as in the Karaite calendar, the Samaritan calendar does not apply the 4 rules of postponement, since they are not mentioned in the Tanakh. This can affect the dates observed for all the Jewish holidays in a particular year by 1 or 2 days. The Qumran calendar. Many of the Dead Sea, Qumran, scrolls have references to a unique calendar, used by the people there, who are often assumed to be Essenes. The year of this calendar used the ideal Mesopotamian calendar of 12 30-day months, to which were added 4 days at the equinoxes and solstices, cardinal points, making a total of 364 days. There was some ambiguity as to whether the cardinal days were at the beginning of the months or the end. but the clearest calendar attestations give a year of 4 seasons, each having 3 months of 30, 30, and 31 days with the cardinal day the extra day at the end, for a total of 91 days, or exactly 13 weeks. Each season started on the 4th day of the week, Wednesday, every year. Ben Dov, head of all years, pages 16 to 17. With only 364 days, it is clear that the calendar would after a few years be very noticeably different from the actual seasons. But there is nothing to indicate what was done about this problem. Various suggestions have been made by scholars. One is that nothing was done, and the calendar was allowed to change concerning the seasons. Another suggestion is that changes were made irregularly, only when the seasonal anomaly was too great to be ignored any longer. Ben Dov, head of all years, pages 19 to 20. The writings often discuss the moon, but the calendar was not based on the movement of the moon any more than indications of the phases of the moon on a modern Western calendar indicate that that is a lunar calendar. A recent analysis of one of the last scrolls remaining to be deciphered has revealed it relates to this calendar, and that the sect used the word Tekufa to identify each of the 4 special days marking the transitions between the seasons. Persian civil calendar. Calendrical evidence for the post-exilic Persian period is found in papyri from the Jewish colony at Elephantine in Egypt. These documents show that the Jewish community of Elephantine used the Egyptian and Babylonian calendars. The Sardica Paschal table shows that the Jewish community of some eastern city, possibly Antioch, used a calendrical scheme that kept Nisan 14 within the limits of the Julian month of March. Some of the dates in the document are corrupt, but they can be amended to make the 16 years in the table consistent with a regular intercalation scheme. Peter, the bishop of Alexandria, early 4th century CE, mentions that the Jews of his city hold their Passover according to the course of the moon in the month of Faminoth, or according to the intercalary month every 3rd year in the month of Pharmothi, suggesting a fairly consistent intercalation scheme that kept Nisan 14 approximately between Faminoth 10, March 6th in the 4th century CE, and Pharmothi 10, April 5th. Jewish funerary inscriptions from Zor, south of the Dead Sea, dated from the 3rd to the 5th century, indicate that when years were intercalated, the intercalary month was at least sometimes a repeated month of Adar. The inscriptions, however, reveal no clear pattern of regular intercalations, nor do they indicate any consistent rule for determining the start of the lunar month. In 1178, Maimonides included all the rules for the calculated calendar and their scriptural basis, including the modern epical year in his work, Mishneh Torah. Today, the rules detailed in Maimonides' code are those generally used by Jewish communities throughout the world. Astronomical calculations, synodic month, the Molad interval. A new moon astronomically called a lunar conjunction and, in Hebrew, a molad, is the moment at which the sun and moon are aligned horizontally concerning a north-south line. Technically, they have the same ecliptical longitude. The period between 2 new moons is a synodic month. The actual length of a synodic month varies from about 29 days 6 hours and 30 minutes, 29.27 days, to about 29 days and 20 hours, 29.83 days, a variation range of about 13 hours and 30 minutes. Accordingly, for convenience, a long-term average length, identical to the mean synodic month of ancient times, also called the molad interval, is used. The molad interval is \displaystyle \frac 765,433, 25,920. Days, or 29 days, 12 hours, and 793 parts. 1 part equals 1/18th minute. 3 parts equals 10 seconds, i.e., 29.530594 days, and is the same value determined by the Babylonians in their system B about 300 BCE. and was adopted by the Greek astronomer Hipparchus in the 2nd century BCE, and by the Alexandrian astronomer Ptolemy in the Almagest, for centuries later, who cited Hipparchus as his source. Its remarkable accuracy, less than 1 second from the true value, is thought to have been achieved using records of lunar eclipses from the 8th to 5th centuries BCE. This value is as close to the correct value of 29.530589 days as it is possible for a value to come that is rounded off to whole parts. The discrepancy makes the molad interval about 0.6 seconds too long. Put another way, if the molad is taken as the time of mean conjunction at some reference meridian, then this reference meridian is drifting slowly eastward. If this drift of the reference meridian is traced back to the mid-4th century, the traditional date of the introduction of the fixed calendar, then it is found to correspond to a longitude midway between the Nile and the end of the Euphrates. The modern molad moments match the mean solar times of the lunar conjunction moments near the meridian of Kandahar, Afghanistan, more than 30 degrees east of Jerusalem. Furthermore, the discrepancy between the molad interval and the mean synodic month is accumulating at an accelerating rate, since the mean synodic month is progressively shortening due to gravitational tidal effects. Measured on a strictly uniform time scale, such as that provided by an atomic clock, the mean synodic month is becoming gradually longer. But since the tides slow Earth's rotation rate, even more, the mean synodic month is becoming gradually shorter in terms of mean solar time. Seasonal drift. The mean year of the current mathematically based Hebrew calendar is 365 days 5 hours 55 minutes, and 25 plus 25 57 seconds, 365.2468 days, computed as the molad/monthly interval of 29.530594 days times 235 months, in a 19-year metonic cycle divided by 19 years per cycle. Concerning the Gregorian calendar, the mean Gregorian calendar year is 365 days 5 hours 49 minutes and 12 seconds, 365.2425 days, and the drift of the Hebrew calendar concerning it is about a day every 231 years. Implications for Jewish ritual. Although the molad of Tishri is the only molad moment that is not ritually announced, it is the only one that is relevant to the Hebrew calendar, for it determines the provisional date of Rosh Hashanah, subject to the Rosh Hashanah postponement rules. The other monthly molad moments are announced for mystical reasons. With the Moladot on average almost 100 minutes late, this means that the molad of Tishri lands 1 day later than it ought to in 100 minutes, divided by 1,440 minutes per day, equals 5 of 72 years, or nearly 7% of years. Therefore, the seemingly small drift of the Moladot is already significant enough to affect the date of Rosh Hashanah, which then cascades to many other dates in the calendar year, and sometimes, due to the Rosh Hashanah postponement rules, also interacts with the dates of prior or next year. The molad drift could be corrected by using a progressively shorter molad interval that corresponds to the actual mean lunar conjunction interval at the original molad reference meridian. Furthermore, the molad interval determines the calendar mean year, so using a progressively shorter molad interval would help correct the excessive length of the Hebrew calendar mean year, as well as helping it to hold on to the northward equinox for the maximum duration. When the 19-year intercalary cycle was finalized in the 4th century, the earliest Passover, in year 16 of the cycle, coincided with the northward equinox, which means that Passover fell near the first full moon after the northward equinox, or that the northward equinox landed within one lunation, before 16 days after the molad of Nisan. This is still the case in about 80% of years, but, in about 20% of years, Passover is a month late by these criteria, as it was in AM 5765, 5768, and 5776, the 8th, 11th and 19th years of the 19-year cycle equals Gregorian 2005, 2008, and 2016 CE. Presently, this occurs after the premature insertion of a leap month in years 8, 11, and 19 of each 19-year cycle, which causes the northward equinox to land on exceptionally early Hebrew dates in such years. This problem will get worse over time, and so beginning in AM 5817, 2057 CE, year 3 of each 19-year cycle will also be a month late. If the calendar is not amended, then Passover will start to land on, or after the summer solstice around AM 16652, 12,892 CE. In theory, the exact year when this will begin to occur depends on uncertainties in the future tidal slowing of the Earth rotation rate, and the accuracy of predictions of precession and Earth axial tilt. The seriousness of the spring equinox drift is widely discounted, because Passover will remain in the spring season for many millennia, and the text of the Torah is generally not interpreted as having specified tight calendrical limits. The Hebrew calendar also drifts with respect to the autumn equinox, and at least part of the harvest festival of Sukkot is already more than a month after the equinox in years 1, 9, and 12 of each 19-year cycle, beginning in AM 5818, 2057 CE. This will also be the case in year 4. These are the same year numbers as were mentioned for the spring season in the previous paragraph, except that they get increment at Rosh Hashanah. This progressively increases the probability that Sukkot will be cold and wet, making it uncomfortable or impractical to dwell in the traditional sukkah during Sukkot. The first winter seasonal prayer for rain is not recited until Shemini Atzeret, after the end of Sukkot. Yet it is becoming increasingly likely that the rainy season in Israel will start before the end of Sukkot. No equinox or solstice will ever be more than a day or so away from its mean date according to the solar calendar. While 19 Jewish years average 6939 d 16 hours 33 minutes 0313 s, compared to the 6939 d 14 hours 26 minutes and 15 seconds of 19 mean tropical years. This discrepancy has mounted up to 6 days, which is why the earliest Passover currently falls on March 26th, as in AM 5773/2013 CE. Worked example. Given the length of the year, the length of each month is fixed as described above, so the real problem in determining the calendar for a year is determining the number of days in the year. In the modern calendar, this is determined in the following manner. The day of Rosh Hashanah and the length of the year are determined by the time and the day of the week of the Tishrei Molad, that is, the moment of the average conjunction. Given the Tishrei Molad of a certain year, the length of the year is determined as follows. First, one must determine whether each year is an ordinary or leap year by its position in the 19-year Metonic cycle. Years 3, 6, 8, 11, 14, 17, and 19 are leap years. Secondly, one must determine the number of days between the starting Tishrei Molad, TM1, and the Tishrei Molad of the next year, TM2. For calendar descriptions in general the day begins at 6 p.m., but for the purpose of determining Rosh Hashanah, a molad occurring on or afternoon is treated as belonging to the next day, the first daya. All months are calculated as 29D, 12H, 44M, 313S long, Mon Len. Therefore, in an ordinary year, TM2 occurs 12 times Mon Len days after TM1. This is usually 354 calendar days after TM1, but if TM1 is on or after 3:11 and 20 seconds AM, and before noon, it will be 355 days. Similarly, in a leap year, TM2 occurs 13 times Mon Len days after TM1. This is usually 384 days after TM1, but if TM1 is on or after noon, and before 2 hours 27 minutes, and 2 hours 27 minutes, and 16 seconds to 3 p.m., TM2 will be only 383 days after TM1. In the same way, from TM2 one calculates TM3. Thus the four natural year lengths are 354, 355, 383, and 384 days. However, because of the holiday rules, Rosh Hashanah cannot fall on a Sunday, Wednesday, or Friday, so if TM2 is one of those days, Rosh Hashanah in year 2 is postponed by adding 1 day to year 1, the second daya. To compensate, 1 day is subtracted from year 2. It is to allow for these adjustments that the system allows 3 85-day years, long leap, and 3 53-day years, short ordinary, besides the 4 natural year lengths. But how can year 1 be lengthened if it is already a long ordinary year of 355 days, or year 2 be shortened, if it is a short leap year of 383 days? That is why the third and fourth diyas are needed. If year 1 is already a long ordinary year of 355 days, there will be a problem if TM1 is on a Tuesday, as that means TM2 falls on a Sunday, and will have to be postponed, creating a 356-day year. In this case, Rosh Hashanah in year 1 is postponed from Tuesday, the third daya. As it cannot be postponed to Wednesday, it is postponed to Thursday, and year 1 ends up with 354 days. On the other hand, if year 2 is already a short year of 383 days, there will be a problem if TM2 is on a Wednesday. Because Rosh Hashanah in year 2 will have to be postponed from Wednesday to Thursday, and this will cause year 2 to be only 382 days long. In this case, year 2 is extended by 1 day by postponing Rosh Hashanah in year 3 from Monday to Tuesday, the fourth daya, and year 2 will have 383 days, rectifying the Hebrew calendar. Given the importance of the Jewish ritual of establishing the accurate timing of monthly and annual times, some futurist writers and researchers have considered whether a corrected system of establishing the Hebrew date is required. The mean year of the current mathematically based Hebrew calendar has drifted an average of 7 to 8 days, late relative to the equinox relationship that it originally had. It is not possible, however, for any individual Hebrew date to be a week or more late, because Hebrew months always begin within a day or 2 of the molad moment. What happens instead is that the traditional Hebrew calendar prematurely inserts a leap month 1 year before it should have been inserted, where prematurely means that the insertion causes the spring equinox to land more than 30 days before the latest acceptable moment, thus causing the calendar to run 1 month late, until the time when the leap month should have been inserted prior to the following spring. This presently happens in 4 years out of every 19-year cycle, years 3, 8, 11, and 19, implying that the Hebrew calendar currently runs 1 month late more than 21% of the time. Dr. Bromberg has proposed a 353-year cycle of 4,366 months, which would include 130 leap months, along with the use of a progressively shorter molad interval, which would keep an amended fixed arithmetic Hebrew calendar from drifting for more than 7 millennia. It takes about 312 centuries for the spring equinox to drift an average of 1/190th of a molad interval, earlier in the Hebrew calendar. That is a very important time unit, because it can be cancelled by simply truncating a 19-year cycle to 11 years, omitting 8 years including 3 leap years from the sequence. That is the essential feature of the 353-year leap cycle. 9 times 19, plus 11 plus 9 times 19, equals 353 years. Religious questions abound about how such a system might be implemented and administered throughout the diverse aspects of the world's Jewish community. Conversion between Jewish and civil calendars. The times below, Moladot Nisan, can be used to determine the day the Jewish ecclesiastical spring year starts over a period of 19 years. Molad Nisan 5779 equals 125. Display style, frac, 1718. Friday, April 5th, 2019. Molad Nisan 5780 equals 1014. Display style, frac, 1118. Tuesday, March 24th, 2020. Molad Nisan 5781 equals 1903. Display style, frac, 518. Saturday, March 13th, 2021. Molad Nisan 5782 equals 1636 Friday, April 1st, 2022. Molad Nissen 5783 equals 124. Backslash display style. Backslash track 1218. Wednesday, March 22nd, 2023. Molad Nissen 5784 equals 2257. Backslash display style. Backslash track 718. Monday, April 8th, 2024. Molad Nissen 5785 equals 746. Backslash display style. Backslash track 118. Saturday, March 29th, 2025. Molad Nissen 5786 equals 1634. Backslash display style. Backslash track 1318. Wednesday, March 18th, 2026. Molad Nissen 5787 equals 1407. Backslash display style. Backslash track 818. Tuesday, April 6th, 2027. Molad Nissen 5788 equals 2256. Backslash display style. Backslash track 218. Saturday, March 25th, 2028. Molad Nissen 5789 equals 744. Backslash display style. Backslash track 1418. Thursday, March 15th, 2029. Molad Nissen 5790 equals 517. Backslash display style. Backslash track 918. Wednesday, April 3rd, 2030. Molad Nissen 5791 equals 1406. Backslash display style. Backslash track 318. Sunday, March 23rd, 2031. Molad Nissen 5792 equals 2254. Backslash display style. Backslash track 1518. Thursday, March 11th, 2032. Molad Nissen 5793 equals 2027. Backslash display style. Backslash track 1018. Wednesday, March 30th, 2033. Molad Nissen 5794 equals 516. Backslash display style. Backslash track 418. Monday, March 20th, 2034. Molad Nissen 5795 equals 248. Backslash display style. Backslash track 1718. Sunday, April 8th, 2035. Molad Nissen 5796 equals 1137. Backslash display style. Backslash track 1118. Thursday, March 27th, 2036. Molad Nissen 5797 equals 2026. Backslash display style. Backslash display style. Backslash track 518. Monday, March 16th, 2037. Molad Nissen 5798 equals 1759. Sunday, April 4th, 2038. Every 19 years this time is 2 days, 16 hours, 33, and 1/18 minutes later in the week. That is either the same or the previous day in the civil calendar, depending on whether the difference in the day of the week is 3 or 2 days. If February 29 is included fewer than 5 times in the 19-year period, the date will be later by the number of days, which corresponds to the difference between the actual number of insertions and 5. If the year is due to start on Sunday, it actually begins on the following Tuesday, if the following year is due to start on Friday morning. If due to start on Monday, Wednesday, or Friday, it actually begins on the following day. If due to start on Saturday, it actually begins on the following day if the previous year was due to begin on Monday morning. The table below lists, for a Jewish year commencing on March 23rd, the civil date of the first day of each month. If the year does not begin on March 23rd, each month's first row. If 29 February falls within a Jewish month on the first day of later months will be a day earlier than shown. For long period calculations, dates should be reduced to the Julian calendar and converted back to the civil calendar at the end of the calculation. The civil calendar used here, Exigian, is correct to 1 day in 44,000 years and omits the leap day in centennial years, which do not give remainder 200 or 700 when divided by 900. It is identical to the Gregorian calendar between October 15th, 1582 CE, and February 28th, 2400 CE, both dates inclusive. To find how many days the civil calendar is ahead of the Julian in any year from 301 BCE, the calendar is proleptic, assumed up to 1582 CE. Add 300 to the year, multiply the hundreds by 7, divide by 9, and subtract 4. Ignore any fraction of a day. When the difference between the calendars changes, the calculated value applies on and from March 1st, civil date. For conversions to Julian. For earlier dates, reduce the calculated value by 1. For conversions to the civil date, the calculated value applies on and from February 29th, Julian date. Again, for earlier dates, reduce the calculated value by 1. The difference is applied to the calendar 1 is converting into. A negative value indicates that the Julian date is ahead of the civil date. In this case, it is important to remember that when calculating the civil equivalent of February 29th, Julian, February 29th is discounted. Thus, if the calculated value is for the civil equivalent of this date is February 24th. Before 1 CE, use astronomical years rather than years BCE. The astronomical year is year BCE 1. Up to the 4th century CE, these tables give the day of the Jewish month to within a day, or so, and the number of the month to within a month, or so. From the 4th century, the number of the month is given exactly, and from the 9th century the day of the month is given exactly as well. In the Julian calendar, every 76 years the Jewish year is due to start 5H4714/18M earlier, and 3D18H12/18M later in the week. Example calculation. On what civil date does the 8th month begin in CE 20,874 to 5? 20874 equals 2026 plus 248x76. In 248x76 Julian years the Jewish year is due to start 248x3D18H12/18M later in the week, which is 932D2H312/18M, or 1D2H312/18M later, after removing complete weeks, allowing for the current difference of 13 days between the civil and Julian calendars. The Julian date is 13 plus 248x0D5H474/18M earlier, which is 72D21H2816/18M earlier. Convert back to the civil calendar by applying the formula. 20,874 plus 300 is equal to 21,174. 211 times 7 is equal to 1,477. 1,477 divided by 9 is equal to 164. Remainder 1. 164 minus 4 is equal to 160. 160D72D21 H2816/18M equals 87D2H312/18M. So, in 20874 CE, the Jewish year is due to begin 87D2H312/18M later than in 2026 CE, and 1D2H312/18M later in the week. In 20874 CE, therefore, the Jewish year is due to begin at 11.30318 a.m. on Friday, June 14th. Because of the displacements, it actually begins on Saturday, June 15th. Odd months have 30 days, and even months 29. So the starting dates are 2, July 15th, 3, August 13th, 4, September 12th, 5, October 11th, 6, November 10th, 7, December 9th, and 8, January 8th. The rules are based on the theory that Maimonides explains in his book Rabbinical Astronomy. No allowance is made for the secular centennial decrease of 1/2 second in the length of the mean tropical year, and the increase of about 4 yards in the distance between the Earth and the Moon resulting from tidal friction, because astronomy was not sufficiently developed in the 12th century, when Maimonides wrote his book, to detect this. This is brought to you by the Praetorian, on both YouTube and Facebook. We thank you for your participation. If you enjoyed, please like, subscribe, share, make comments. We love feedback.